We're still waiting for others. All class rep. Anyone have any question to ask? This is our week 2. And then we have already actually covered the first chapter for the last 2 lecture, which I already posted the video. So those of you who need to replay and go through the notes, you are welcome. And make sure you go through it and so that you can prepare for your tutorial, which already started this week. Right? Follow your own tutorial group and your tutors. Okay, any questions from anyone? Class reps. So just a reminder again for everyone, I already announced that in week 7 and week 9, the assessment for the quiz and also the e-test. Right, so you all know the time, right? So block your calendar, block the time from 6 to 8. Make sure week 7, week 9, all class do not go anywhere, all right? And hope that you do not put any replacement or whatever on that time, on that week. Saturday, it's a Saturday. I'll just remind you all again. So, block the time. Once we enter the campus, we give you all more further details. Okay, everyone? So, we are still waiting for others to join. Any questions from anyone? Okay, if don't have, we will start now. I believe you all have gone through the first chapter, right? And you're saying that the last part that we do is for this drawing the histogram and also the ogive for this continuous data as well as discrete data. After that, we plot them on the graph and we use that to estimate some equations, right? For histogram, in this chapter 2, we are going to use it to estimate the mode, and for the ogive, or we call it cumulative frequency polygon. Some textbook, they call it cumulative frequency curve. Use it to estimate the median and also the quartiles 1 and quartile 3. Okay, now let me share my screen first and I will start recording. Okay, we will start now. In this chapter 2, we are going to look at more concept. Now, because in chapter 1, we already see why we learn statistics, right? Basically, we are trying to process and then analyze and interpret the data. Okay, the raw data that we analyze it and then we interpret or we give comment what we can get the conclusion from the data. So in this chapter 2, we're going to use this data to give us more explanations as well as the indications of the relevant informations. For example, mean, median. Okay, after we calculate all this, what are the interpretation or conclusion we can get from the data? Remember, we also learned sample and population, right? Based on the big group, right? We select certain percentage and then we do analysis and so on. After that, we can calculate all the measurement. So we are going to look at this central tendency for the first part. After that, we try to calculate mean, median, and mode. Now we have 2 types of data in chapter 1. Remember the raw data and also the group data. Okay, so in this topic, the measure of central tendency is a single value that can be taken as the summary value for the data set. Summary value means after you calculate, based on the value, you're going to interpret it. So the 3 types which often used for central tendency is called mean, median, and mode. Now, in chapter 1, if you remember for this histogram, right, we talk about skewness, right? I hope you still remember this skewness, right? Quick example, let's say you have a histogram, something like this. Remember the shape. This is skew positive or skew negative. Remember or not? We did that in last Saturday, right? look at the center here, right? And then this is the peak. So the peak is at the left. This is positive skew, right? So how we know this is positive skew? Actually, there are a few ways to look at it. Either you draw the normal curve up. I believe some of you already know what is called normal curve. You may have learned before, but for those of you who never learned before then we come to chapter 4, then I will show you this normal curve. Remember this one? Some of you have learned this before. You draw this normal curve, right? Anyone can remember this normal curve? This curve. If you talk about like this, this is what? Have you all seen this curve before? It's called normal. Remember this? Normal curve, right? If remember last Saturday, we also look at if you have a histogram, something like this. Remember? This one is called what? Symmetry, right? Remember? No skewness because the left and right, the peak is almost at the center there. So if you draw this normal curve, you can see it's very normal. Coming back to this positive, you can see here, this is your right tail, very long one. This right tail means longer than the left tail. We call this right tail. I introduce all this first because when you come to chapter 4, we are coming to cover everything. So this is called right tail. This is called left tail. Right tail longer than left tail is positive skew. This one, the right and the left is almost the same. So it's called symmetry, no skew. Now, the other thing that we are going to learn today, mean, median, and mode, we can also compare these three values. If the mean more than median and more than the mode, then it is positive skew. If the other way around, it's called negative skew. We are going to learn that very soon. So some people, they compare with these three values. Some people, they look at the histogram or the normal curve to check the skewness. Okay, everyone? So in future, when you do your survey or project, when you, after you've done the survey, you ask the software, right? Remember the software, you ask them to calculate the skewness for you. They can straight away give you the value. From there, you can interpret. If you want to plot the graph, can. Normally, people draw histogram and normal curve. Some people interpret using the mean, median, and the mode. Okay, everyone? So that one, I will leave that to your next statistics, future subjects if you have. Okay, now let's come back to our calculation again. I'm sure everyone knows what's called mean. We call it average. Mean is the most used compared to these three, mean, median, and mode. The most used one is called mean. Everybody know what's that, right? It's the average of a group of data, meaning that you sum it up, all the observations, and then you divide by the number. Let's say I have x1, x2, x3, x4, x5. Let's say I find number here. So how to find the mean? The mean is actually total of the x. Remember this symbol? Total means you take the x1 plus x2 plus x3 until the x5, then you divide by n, means you divide by 5 number here. So this is your x individual value, n is the total, sigma is the, we call it summation, sigma, this is called sigma, total of all the observations, or we call it data. So this is for raw. Okay, now, example, find the mean for 2, 2, 3, 4, 0, 6, 2, 1. I'm sure this one no problem. Everyone know how to plus it up, divide by 8 numbers. So you get 20 over 8. Calculator. 20 divided by 8 is how much? 2.5. Any questions? Okay. As usual, everybody, anyone have any question, you can voice up if I'm too fast or you want me to repeat again. Now, this is what you learn on the first and second chapter, raw data. There is no frequency, correct? There's no table one, remember? So your data will be displayed like that. Second type of data, we learned that group. Remember group? Group is something in a table one, right? Then you have a what? frequency. So X is the class mark, F is the frequency. Oh, okay, everyone, remember frequency, right? X is the class mark. Remember how to calculate class mark? How to calculate class mark, everyone? Upper boundary. Remember boundary plus the lower boundary divided by 2. Class mark means midpoint divided by 2. So the formula, total summation of each class, for each class, you take the frequency, multiply the class mark for that class one by one, then you total up, divide by the total frequency. Okay, can we look at this example? Now, the following example shows a table of frequency distributions, which is about the lengths of metal pipes. Metal pipes, you all know what's that, right? Pipes that made of steel, and the length of it. So you can see that this is in centimeter, and the number of metal pipes, for example, between 10 to under 20 centimeter. How many pipes? 3. Okay. Another example, 50 to less than 60 centimeter, we have about 34 pipes. So this is basically our frequency. Okay, group data. So remember this word under. What's the meaning under? I always want to test less than. So is this discrete or continuous? Kim Sen, Kiaman, Yong Kiet, most of you say less than. So can I ask, is this discrete or continuous? Length of metal pipes. Length can be what? Point form, right? Last week I asked you all to look around yourself. The variables can be measured in discrete. Some of the variable or data can be measured in point form, right? So length means how long? How long can be what? 20. Yes, ma'am. 12.5 centimeter, 13.2 centimeter, correct not? So you can see here under. Remember, for continuous, we can use this as a class limit. So the next class will be what? Less than 20 means 19.99999. But the decimal point very small, 19.999. So we can actually write it as what? 10 to 20. This one 20 to under 30 means. You can see here, all these are until 90 to under 100. As I said, less than means very small, 90.999. So we can might as well take it as 10 to 20. Remember, I say you can ignore this stuff. Fair enough. So this is our boundary. This is our class boundary. This is our class limit. So make sure there's no gap. No gap. Continuous data is okay one, don't worry. The point form is very small, so we can actually ignore it. So continuous data usually no problem, no gap. But for discrete, you all have seen that, right? When there's a gap, you have to plus minus 0.5. So here, this is our class boundary. Use this class boundary to find what? Our X. This is our class mark. Otherwise, you cannot take frequency multiply the class mark. So what you're going to do now, you can see here. So you see the length, I already write in the dash form, no more less than. This is our class boundary from here. And then this is your frequency, 3, 7, 10, 16, up to 4. Okay, what is your total frequency here? Can someone tell me? How much? 100. Wang Liyan, Liu Dongcheng, others? 100, huh? Okay, now we need the class part. So how do we get 15? 20 plus 10. 30, right? Divided by 2 is 15, no? Okay, the rest you can do it, lah. How much is this? 50 divided by 2 is 25, oh? Next, 70 divided by 2, 35. So you see that here, you can see, remember the class size, everyone. Do you still remember class size? Upper minus lower, right? So it's 10, 10, 10. Or you can take the class mark. 25 minus 15, also 10. 35 minus 25, also 10. Oh, so you can see that the class mark is consistent and the class size here is also equal. Okay. All right, now you need to have one column here, everyone. So you build one column here, you build second column here. This one will allow us to take frequency multiply the x. You see this one? Frequency multiply. So you take each of the class. For example, 15 multiply 3 is 45. Okay, 25 multiply 7. How much is this? 175, right? Can I give you 10 seconds? Calculate all this. Then total up for me. How much is this? Of course, you don't multiply wrongly. Multiply wrongly or you plus wrongly, then everything wrong. How much is the total FX? 5420. Okay, very fast. Those of you who are still doing, never mind. Those of you who are confident in your answer, you just give me the answer. Okay, now the mean total of FX is 5420. You divide by what? The total frequency, which is 100 lah. So you get 54.2 centimeter. Okay, not everybody? So what is the comment? So you see, most questions they ask you to comment or interpret. You see the tutorial question or passive question, they ask you to interpret or comment. So how do you comment? We're talking about what? The length of pipe, right? How long, right? So we must use the word, the average. The average means mean length of the metal pipe is 54.2 centimeter. So everybody take note. If the question asks you to comment or interpret, you must make sure you write the comment. If you don't write this, you will lose 1 mark. So you just simply use the word, the average length. The average length of the metal pipe is 54.2 centimeter. Any questions from anyone? Now this is based on continuous data. So no gap, so no issue lah. Don't need to plus minus 0.5 lah. We just use this as a class boundary. Okay, do we have one example? Same thing, the table here shows the frequency distribution for daily production level. This is in units, everyone. Production level means it's like a factory or manufacturer, daily production. So let's say we don't know what is the item, what's the product, but let's say it's calculated in units. Units usually is what? 1 unit, 2 units, right? In what? Physical, actual number. So it's what? In the integer. So it's what? Discrete. No point form. For example, 1 handphone, 10 units of handphone, 5 units of table, 20 units of TV, 100 units of washing machine. All these are what? In unit. Everybody okay? So we don't have 1.2 TV. Okay, we cannot say 3.6 cars. All this must be what? Round integer unit. So it's a discrete. That's why you can see here, there's a gap here. 17, 18, right? 22, 23. Remember, there's a gap by 1. So the production here, based on the number of days, for example, 13 to 17 units, there are 2 days that produce this range of production. Okay, let's say 4 days manage to produce between 38 to 42 units of production and so on. So calculate the mean. Again, this is group data. Can you calculate for me, everyone? do the same. Now, we start to wonder, since we have done last two lecture, what did I say? You must close the gap, right? There's a gap here. So you will wonder, do I need to close the gap? If you look at the answer here, you see, I will take this and put it as here, right? Then I find my class mark. 17 plus 13, 30. Everyone listen carefully. 17 plus 13 is 30, right? Divided by 2 is 15, right? Then you wonder, how come I never plus minus 0.5? Because there's a gap here. So I can suggest to you, if you worry about that, might as well this is class limit, right? If you worry, then okay lah. To be consistent, I propose this. You take this as a class boundary, meaning that you plus minus 0.5. Close the gap. So 12.5 to 17.5. Second class, 17.5 to 22.5. And do until the last one, 47.5 to 52.5. Can we do that? Yes, you can. So I take this as a class boundary here. So the first one, I will take this 12.5 to 17.5. The second class maybe 17.5 to 22.5, right? Okay, now if you want to check again what's your class mark, remember class mark, we take the upper plus the lower. 17.5 plus 12.5, you still have 30, right? 30 divided by 2 still 15 also. See or not? So whether you use the class limit or you use the class boundary for discrete data, no issue to find the midpoint. It's not affected by either you close the gap or not close the gap. However, I worry some of you may confuse. Then they say, how come I want to find midpoint? I can take the class limit one. If you worry, then I propose that. That's why I change, as long as you see gap, change to plus minus 0.5. So instead of using class limit, you use class boundary. That's why I say you put your class boundary here. So this one you don't see. Cannot. So you take upper plus lower, still 30, divided by 2, still 15. So can you do the rest for me? Anyone don't understand that? So one by one you plus upper and lower divided by 2, you get your class mark. So this is your frequency. Can someone tell me what is your total frequency here? How many? How many days? 62. Correct. Okay, now you build one more column here. F times x, 15 times 2, 30. The rest you times. Make sure your class mark is correct. Okay, times. And then I want to know what is your total fx here. Anyone got the answer? 1725. You get who? So what is your mean? Total of fx. So it doesn't matter whether it's a continuous or discrete, right? The formula is still the same. And this is the units. So 1725, you will wonder, I get 27.82 units. This one, no choice. As an exam purpose, I mentioned that, right? You can write the decimal point. So the average daily or the mean daily production is 27.82. Okay. The comment, right? Some of you say the average or some of you say the mean. Both also can. No issue. Both also can. So everybody clear? You can use class boundary to be consistent. All right, now here I would like to spend a short while explain to you. Now, remember on the first lecture we talked about population and the big group, right? Is population, and then you take out a small sample. This is your sample. Remember, so select a few percent, some or a few lah. Okay, items from the population we call it sample. Now, the mean computed from population data is called mu. We pronounce it as mu. So this big group, the population that you calculate is called mu. So this is mean population. So I write here, this symbol is called mu, M-I-U, not meow, mu. This is a Greek symbol, like a U, but crooked lah. So this is for population mean, the big group one. If you find the mean for this big group, this is mean. And the mean that you calculate from sample for the small one, which is a symbol of X bar. We call it X bar. X, and then on top here, got a bar here. So this is a sample mean. Okay, two different symbols for different definition. One is the big group population, we call it population mean, and one is for the smaller group, which is sample lah. We call it sample mean. I always, can you all remember these two symbols? I don't want you all to simply use the symbol, especially in chapter 4. When I always ask people, do you know what is this symbol or not? They don't know. Until they finish your whole courses, they don't know. They can't remember. I say, how come you cannot remember? Have you seen this before? They say, yeah, maybe. So, take note, page 3, chapter 2, we already learned this all. You cannot tell us that you don't know what is this and what is this. Both also mean, but one for big group, one for sample. Any questions? Something like you see the person face, but you don't know the name. You know what I mean or not? You see your friend, oh, I remember him, I remember her. You remember the face, but you don't know what's the name. You don't know his name or you don't know her name. Can. So you see the symbol, you don't know the name. Some people remember the name, but don't know the face, can't remember the face. Cannot, you must remember the face, you must remember the name. You understand what I mean, right? It's not a joke, but I hope you all take serious about statistics, because there are a lot of symbols, a lot of definitions. If you cannot remember the symbol or the name, when the question asks you to find, then you also can't kabut lah. You don't know which one are you supposed to find. Okay. So we go on to the next one, median. Remember, we have to look at three things: mean, median, and mode. So we done mean. Let's go for median. All right, what is median? It's the middle value. I'm sure some of you already seen that. Median is the middle value. It is important that the data must be arranged in ascending or descending. Before you find the median, you must arrange the data either in ascending. What is ascending? Ascending means small to biggest. Ascending. Descending means the other way around, biggest to smallest. So you have to arrange before you can locate the median. For example, let's look at the raw data. I have 10, 5, then I have 7, I have 8, and then I have 14. Okay, can you see this 5 number here? Is it arranged already? No, right? Not arranged, right? So you either arrange from small to big or big to small. You cannot simply arrange one. So I rearrange I need to rearrange it. So let's say I rearrange. Usually people rearrange from small to big. So the smallest, let's say I take 5 here lah. Then followed by what? 7, followed by 8, followed by 10, and the last one, 14. Okay? Usually people arrange from small to big. Can? Now, we are going to look at raw data, and after that, group data, like the mean just now, right? We look at the raw data first, and then we look at how to find median for group data. Okay, before we go that, what is the purpose we find median? For mean just now, right? For mean, you see a mean, usually after you calculate the mean, you comment what? Comment the result. So usually you say the average or the mean of what is equal to what, right? You comment lah. But for median, you find the middle value. Let's say back to this example, 5, 7, 8, 10, 14, right? Right. Now how many data here? 5, right? Now we use this symbol n. N represent the number of data. N. So 5 number here. Now middle value means you take 1, 2, 3, 4, 5, right? 5 number here. Where is the middle? You look at this 5 number lah. Where is the middle one? 8, right? This is the middle value. So we will call this as median now, because the location is the middle. Any questions? All right. Now, why we need to calculate median? So this is the comment. After you calculate or you find the median locations and determine the value of the median, this is the comment. As I said, 50% half mark. Middle means half. So the way to comment the median being the middle value implies that 50%, or we call it half of the observations. Usually this is how we write. We say that 50% or half of the observations will be more than or equal to the median value, and another 50%, or we call it another half of the observation, will be less than or equal. So half more than or equal, another half less than or equal. Meaning that if I take this sample, again the example here, we know the median is 8, right? So how do you comment? 50% here less than, or we call it equal to 8. 50% less than or equal to 8. And then another 50% here. This is more than or equal to 8. This is based on the symbol, but you don't write like this, everyone. You write in sentences, okay, which we are going to learn after this. So half, 50% less than or equal to 8 to the median value. Another half here, 50%. So this is 50%. Then this one, another 50%. This one is more than or equal to 8. Okay? This is how we comment. All right, are you ready? How we determine the median for raw data? Back to here, how we know this is 8 and not 7, not 10? Because based on what? 5 number. So you see this formula for raw data. First thing, arrange. Okay, you see, we arrange already, everyone. Don't forget to arrange into ascending order. As I said, most cases people arrange in the small to big. All right, now after that, you want to locate the median location. Median location here is given by this formula. Very simple. Okay, but you take this n plus 1 divided by 2. N is referring to the how many numbers? You plus 1, then divide by 2. This is called median location. Call it location of median. Okay, and then the N here, as I say, is the number of items of data, right? And then if the data set consists of even number, you ask yourself, back to here, if I have 5 number here, so based on this 5 plus 1 is what? Based on this, everyone, 5 number here, right? So I take 5 plus 1 is what? 6, right? Divided by 2 is third. So third location. That's why we call this number 1, number 2, number 3. You see, number 3 is our median location. That's why I write here median is 8. Okay, you just take n plus 1. Now, if you wonder if I have an even number, so what should I do? The median will be the average of the 2 middle values. This is how we do it. If you have an n is even number, for example, like you see this one, okay, calculate the median for these completed components by 9 employees. You see here there are 9 employees. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the completed works. So n here, sorry, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. This is a 9, odd number. Let's find the median. Okay, before you find the median, arrange 4, 5, 5. We're still talking about odd number first. 4, 5, 5, then followed by 6, 6, 6, 3, 6 here, 7, 8, and 10. Arrange first. So the n is 9. So first thing, what is your location of median? Again, n plus 1. 9 plus 1 divided by 2. Okay, so we have 10. 10 divided by 2 is what? 5th item. The location is number 5. So 1, 2, 3, 4, 5. So this is our median. So the median is what? 6 components. Okay. Now for odd number, no issue. For odd number, no issue. You see, this is 5, right? 5 number, 5 digit. And this is 9 digit, example, no issue. Because in plus 1, you divide by 2, you will get the round number as a location. But for the even number one, you must take the average of the 2 middle values. Let's look at one example. Find the median for this. How many number here? 1, 2, 3, 4, 5, 6, 7, 8. So the n here is 8, right? 8 is even number. If we have even data, this one is already arranged from small to big. So if I want to find the median location, again we use n plus 1 divided by 2. So 8 plus 1 divided by 2 is what? 9 over 2, which is 4.5. So what's the meaning 4.5, everyone? 1, 2, 3, 4. This is 4. This is 5, 6, 7, 8. So 4.5 between 4 and 5. That is the problem. For even number, when you plus 1, you divide by 2, you will get a point form, which is between 4 and 5 here. So the definition here, you take the middle, 2 middle value, take the average, you add it up. What's the meaning average? Add it up, divide by 2. So here, you have to take 43 plus 45, which is what? 88, right? Take the average, you divide by 2, so it's 44. This is your median. For raw data, we can do like this. Any questions from anyone? Okay, this is the way to locate a median For odd number, no issue, but for even number, you have to take the average of the two middle values. Okay, now that is for raw data. Remember the location, you must take n plus 1. Let's go to group data. For group data, same thing. Remember for group data, there is a frequency. Remember there's a table, there's a frequency. So calculate the cumulative frequency to position the items again in ascending order. Now for group data, there are more works to do because group data have frequency. So you're not given the list like this because this is raw data. There's no frequency, so easy to locate the median. Just use this formula, n plus 1 over 2. But for group data, we need to find the cumulative frequency. Everyone, do you still remember last Saturday when we do the OGIF? Remember OGIF? What is cumulative frequency? Chapter 1. Cumulative means what? You keep on plus. Remember the OGIF? So here, we have no choice. We are going to use the table form. And then we remember again, you look back your OGIF, we take the upper boundary. I'm not going to show back the screen now, but you look at your chapter 1. The upper boundary, you take it and put it into a box. Remember the table. Then your right hand side is your cumulative frequency. So we are going to do the same here. After you do this, then the step 2, you have to locate the median class. And the location of the median class is given by this. Everyone take note, n over 2. What's the difference between these two formula? This one got plus 1, right? This one, no plus 1. So for group data, no plus 1. Only n. Can you remember the two different there? Okay, right. Step 3, after you already find the locations of the median from the cumulative frequency, and then you're going to apply the formula called linear interpolation formula to find the median. Okay, one of the method. This is the formula. Median is given by Lm. Lm is the lower class boundary. Remember class boundary? We take the lower side one, plus the Cm. Cm is, we call it class size. Remember how to find class size? Okay, for that median class, okay, you find the median class, right? You determine the median class, then you check the class size. That's our Cm. Divided by Fm. Fm is the frequency of that median class. Okay, then you times bracket n over 2. Now n over 2 here is the same as n over 2 here, which is the location of the median minus, okay, this one, total of, remember this is summation, total of the frequency m minus 1. M minus 1 means preceding. Preceding means before. M minus 1 means before the median class. You need to total up. Total up means is cumulative frequency. Okay, so I believe some of you have learned this in your secondary school, similar to this formula, right? Maybe a bit different, but the concept is the same. For those of you first time learning this, you have to practice more. Okay, memorize with yourself with all these symbols. You do one questions, I'm sure you can follow. Not very difficult. You just have to make sure your CF is correct. Total up it. Okay, we do it one exercise now, and then you have to locate the median class using n over 2, and from there, after you find the location of the median class, you determine the median class really, and then you apply this called linear interpolation formula to find your median. All right. Now the second method to find the median is using OGIF. OGIF, which you learned last Saturday, right? Use the graph. We try one example also. After you draw the OGIF, we can estimate the median using half of the total of numbers of data, n half n. From there, we can estimate the median. All right. So we are going to use these two methods now. Let's look at one example for group data. Are you ready? Okay. Now, the same example for meta types. Remember this one we used just now? Where is it? Here. Same example. This is the class boundary. Continuous data. This is the frequency, everyone. So the total frequency is 100. The class boundary is here. And then, okay, now, everyone, the class boundary, total frequency. So actually under you can write as 10 to 20 lah. You can ignore the less than symbol. So everyone, just write back again this class boundary. Okay, this is your frequency given by here. Now you need to build one more column here. This is called cumulative frequency. Remember last week, everybody? Those of you who forgotten, can you check back your chapter 1 how we find this CF? Okay, CF, cumulative frequency. So the first one is 3, right? Okay, how you get 10 here? Plus 7. Am I right, everyone? Additional means plus lah. Then next one, 10 plus 10 is 20, plus 16, plus 34, plus 13, 8, 3, 10, 20, 36, 70, 83, plus 7, 90, plus 6, 96, plus 4, 100. Remember I say this one and this one must be same. Remember last Saturday? If you add carefully, it must be same. So this is what you need to do. Build one column for CF. Why? Because step 1 say here, you need to calculate the CF to locate the median in step 2. So next we use n/2 to find the location of the median class. So here, what is our n? N here, everyone, n is the total of frequency. Remember I mentioned this? It's the same. So your frequency total is 100 lah. So that means your n is what? 100. So the median location, n/2, remember? Only plus 1, n/2 is 100 divided by 2 is 50. Now, 50, based on this cumulative frequency, step 3, you from the step 2, you know the median class. Based on the CF here, let's look at the CF again, not the frequency. Look at the CF. 50 fall into which classes? Look at the CF, not the F. So you see the number here, 3, 10, 20, 36, up to 100, right? Which one of these are first number, the first number here, which is more than 50? Can everyone tell me? Can anyone tell me? $70? Which one of this number more than 50? The first one. Yes, 70. All these number 3, 10, 20, 36, all is smaller than 50, right? We pick the first number. So this is the first number more than 50. So this is your median class. Or you can write here, median lines means median is somewhere around in these lines here. So this is your median class, 50 to 60. Now remember everyone, by the way, this is continuous, right? Continuous, because there's no get one. So we take 50 to 60 is your median class. So you already locate the median class, step 2. Next, step 3, you use this formula to find your median. Are you ready? Okay, so I write down the formula again. What is your LM? Lower class boundary here, which is your 50, right? Your median class is 50 to 60. This is lower, this is upper. So what's your lower class boundary? 50. Class C is what? Class size. So what's your class size? How to find class size? 60 minus 50. Okay? Upper minus lower boundary. 60 minus 50, very obvious, is 10. Anyone cannot follow, you let me know. Divide by FM. What's FM? FM is the frequency of the median class, of that median class. So your median class is this one. Your frequency is 34. 34, not the 70. This is frequency. This is cumulative. So be careful, everyone. Differentiate between them. So 34. Multiply n over 2. N over 2 is 50. Minus, okay, this is the one. Total frequency median minus 1. What is that? Cumulative. So now you have to look at CF of the preceding, before, just before the median class. So go back to your CF here. This is your median, right? Median class. Before is this one. After is 83. Before is 36. This is your 70, your cumulative of the median class. Before is 36. So here, minus 36. Okay. Now, this one you have to look at CF. This one you have to look at frequency. Be careful, everybody. Calculator. I get 54.117. Am I right? Anyone get this 54.118? Yes, sir. Now, can I comment something? You see, your median class is between 50 to 60, right? Now, we don't know what is the median yet, but the median value must be between 50 and 60. So you see our answer after you calculate everything, right? The median is 54.118. Make sure, listen carefully, make sure your median value here is between 50 and 60, between here, this class. Let's say if you get the median here is 61 or 60 point something, is this correct? Cannot, because if you get 61 or 62 or 60 point something, cannot really, because the upper is 60. Or let's say you get 49 point something or 48 something, cannot, because your lower is 50. So your median value must be between this class. Can or not, everyone? Okay, now how do we comment? This is the comment. Remember, how do we comment median? Where is it? Sorry, let me just go back to the comment again. Where's the comment of the median? here 50% of the data will be more than or equal to the median value. Our median value is 54.118. Okay, and then another 50% of the data will be less than or equal to the 54.118. All right, so let's fill up this comment. 50% of the, you must mention metal pipes are having lengths less than or equal to what? 54.118, and another 50% of the metal pipes are having lengths more than or equal to 54.118. So you want to see this word, 50% less than or equal, another 50% more than or equal to the median. Okay. Anyone have problem with the formula and the comment? Okay, how many Sirin Chua, why the boundary is 15, not 49.5? Sirin, because this is not discrete, this is continuous. There is no need to close the gap. No gap ma. Remember, continuous data, no gap. You see, no gap, so we no need to plus minus 0.5 ma. Sorry. We have learned that last week. Okay, Chen Kim Sian asks how many decimal point. You can take 3 or 4 decimal places. Usually we take 4, but here I take 3. Can all right. Any questions from anyone before we go to the next example? Okay, now the next example, this is back to our same example just now, the production level. Remember this one? Production level in the number of units here. This one, discrete. This is discrete, because this is a number of units. No decimal point. It's an integer. So just now we look at this is continuous. So let's look at one example. If you have a discrete, then you be careful here. The production, as I said, units is integer. So you can see here 13 to 17 first class, 18 to 22 second class, and so on. Now you can see there is a gap. When there's a gap, you need to close the gap. So you need to plus minus 0.5. Tiêu Dongsheng asks why is 36 here. Before. This is your cumulative. See this word here? Cumulative. So we look at the before. So you see a CF here. This is your median class, 70. So you have to look at before. Before is 36. So minus 36. Okay or not? All right, now here, so when we want to find the ogive, median, using the same formula, and now we look at ogive after this. So get your graph paper ready. Now, before we use the formula, remember we have to close the gap. So I'm showing you here. This is your class limit. Okay, be careful. Now your class limit, you cannot use this. You must change your what? Plus minus 0.5. Close the gap. If you don't use this, you use the class limit, your answer will be affected because your plus minus 0.5 there. So that is what I already highlighted many times, everyone. When you do a tutorial, be careful. You check if there's a gap. Whenever you see a gap, you know you should close the gap. Close the gap. This one no need ma. This one no get ma. Okay, now can you do the rest for me? Of this? This is your frequency, the number of days, right? Okay, what's the total frequency already? 62, is it? That one not important, no? Okay, so finish already? Okay, now as like our continuous data, we also for discrete we also have to build a CF. Remember this one? Okay, the first one 2, then plus 22, 24, plus 10 we become what? 30. 4 plus 14 we become 48. Plus 3 become 51. Plus 4 55, plus 6 61, plus 1 62 long. Oh, so your total is the same. Okay, median location of the how many items? 6 over 2. Sorry, n over 2, which is the value of the 62 over 2, which is 31 now. Oh, 62. Remember, n over 2 are normally plus 1, 1. So the total n here is 62. Divided by 2 is 631 now. So 31, you look at here. Which of this cumulative, the first number more than 31? Which number more than 31? Yes, correct, 34. Oh, like what you have done for the continuous just now. 34 is the first number more than 31. So this is your median lies here. In other words, you can say the median somewhere around here lies between 23 and 27. So your median class is 20. Sorry, your median class, you cannot use this. You must use the plus minus 0.5. So 22.5 to 27.5, not 23 to 27, everyone. Do not use this. You must close the gap. If you don't close the gap, you will use the lower boundary as 23. Am I right, everyone? If you close the gap, your lower boundary is 22.5. Is there any different? Of course, different by how much? 0.5. It's a lot already, That's why your answer will be different. Okay, so let's find the median class. LM 22.5 plus the CM. What is the size? Size is what? The upper minus the lower. So you get 5. Okay, divided by FM. FM is the frequency of the median class. So 10 times n over 2, 31, minus the, this one is what? Cumulative before the n minus 1, just before the median class. So 34 is your median class, before is 24. This is the before. So minus 24. We calculator 7 times 5 divided by 10 plus 22.5 is 26. See again, make sure 26 is between 22.5 to 27.5. Make sure the range is sufficient. Okay, or you can say that the median is in between the classes. Okay, everyone. How do you interpret the median here? Let's say I want to interpret comment. Let's say can you write this comment for me? How do you comment this median? Can you learn how to write yourself before I give you the answer? So how do you write? 50% of the what? The units is the value, okay, 26, and 50% of the what? Of the production level, or 50% of the production level has less than or equal to what? 26 units, and another 50% has more than or equal to 26 units. Okay. Okay, this is based on the formula. If the question asks you to use formula or tutorial questions, when you do your tutorial, you see if the question asks you to use formula, then you use formula. Now, the second method, as I mentioned, is using Ogive. Remember last Saturday, I hope everyone attended the lecture. Those of you who missed the lecture, you may need to catch up, or you watch the video or ask your friends. Okay, so let's look at Ogive. Do you have graph paper now? I hope everyone buy the graph paper, so when you do your tutorial, you can present for your tutors. Okay. Now this is the Ogive. Remember, you start from this is your class boundary for production units. This is the number of days. Remember, for Ogive, we use what? Cumulative frequency, not the frequency. Remember or not? This is your title, less than Ogive, or you can say cumulative frequency polygon shows the production of factory for 62 days. Remember to write your title. And this is the scale. Remember, I mentioned the scale. Maybe you can put 2 cm for 5, right? 5 unit. Make sure your graph is not too small or too big. So you can start here 12.5. Push everything to start with the 0. Don't waste your space. And then here, for the y-axis, maybe you can take here 10, 10, 10. 2 cm for 10 unit. Or 1 cm for 1 unit. If it's too small, then you use 2 cm. Okay? Now, you start from 12.5 to 17.5. So you start from 12.5 to 17.5. You start from 0. Remember last Saturday, you start from 0. Clear not? Ogive must start from 0. So I put a remark here. Ogive must start from where? Remember last Saturday I mentioned this? How many of you forgotten? Tell me yes or no. Can you answer in the chat box? Answer yes or no. I told you right last Saturday, Ogive must start from 0. Yes, isn't it? Okay, so So back to our table just now. Where is it? Here, right? What should we do? We should beat the table. And if you remember last lecture, I will take this upper boundary, upper one here, and you take this CF, build one table out. Correct? Take the upper one here, the lower don't care. So we take 17.5. So if you remember, can I draw here? Enough space or not? Up to what? 52.5. Am I right? And then your CF here start from 2. This is the units. This is the less than CF. So start from where? 2, is it 2? 24, 34, 48, 51, 55, 61, and 62. So as I said, object must start from 0, cannot start from 2, isn't it? Everybody? So what do you need to add? 0 here. Am I right? Okay, then here you must add what? One more upper boundary. How you know what is the upper boundary here? You see here, this is 5, 5, 5, right? Difference by 5 ma. So minus 5 is 12.5. Huh? Or you look from here lah. You add, this is your first class boundary ma, right? It's 2. So if you add 0 here, then you add 1 class boundary. This is what? 12.5. So this is 12.5. Huh? Then from here is what? It should be minus 5. Then it should be 7.5. Huh? Oh, minus 5 ma. Minus 5. So it's 7.5. Sorry. So this is your upper boundary, 12.5. Can you see that? That's why you add in here. So now you have this table. Remember, you're going to plot this for your production unit for class boundary, starting from 12.5. You see or not? Not 17.5, everyone. If you start from here, we can see that many people start from 17.5. And surprisingly, they can start from 0. No, 17.5 is 2. Here. Make sure you match correctly. So you must start from 12.5 with 0 here. Next, 17.5 is 2. So you find your graph paper 2. Next, 22.5 is 24. So 24 is somewhere around here, you see? 20, right? 24 is somewhere around here. You need to use graph paper. 27.5 is 34. So 27.5 here is 34. Then 32.5 is 48. 48 somewhere around here. 37.5 is 51 here. 42.5 is 55 here. 61. And the last one, 52.5 is 62. Then use your ruler. Use ruler to join them, not curve. We standardize all, use the ruler. Draw a sharp line, join all the points. So this is your ogive. You see the ogive going up, it won't come down. Why? Because this is cumulative. See, from small to the highest. So your graph ogive is going up, it won't come down. Everybody take note. Okay, now how we use the ogive to estimate the median? Remember the median is what? N over 2, right? So it's 61, right? Divided by 2, which is, it's 62. divided by 2 is 31. 31 is from where? Here. Everybody, look at the number of days, 31, right? So from your graph, this is your 31. Then what do you do? What you do? You need to find the units, how many production when the number of days is 32. So 31. So you draw here one line, horizontal, hit here. Remember last week we have seen this. Draw one line from 31. Touch your object, you draw down. Okay, everyone, you try after this. From here, you estimate around 26. So everybody, you try, use the actual graph, whether you can get 26 or not. If you get 25 point something, remember you're only allowed to take plus minus 0.5, right? Not too much different. So plus minus 0.5 is still okay. If you can get 26, better. So you see from your graph and your calculation is about the same. Okay, sometimes the graph can give a bit different compared to the calculation because graph is quite hard to estimate. Accuracy will be affected. But try not to be so much difference between plus minus 0.5. So the scale is very important. Okay? Right. So this is the table that you all need to fit for upper boundary versus the less than CF. Start from 0. Any questions? Anyone cannot follow? Yes. Kwan Meki asked, do we need to draw the new table for the object? Yes, everyone, you have to draw this. Draw this. Some question give you marks for this. If the question mentioned draw the frequency table to show the CF, then you draw this. But I've noticed that many people don't draw this. They straight away understand, they take the upper versus the CF. Some people, they never draw, but we still give marks. We still give marks. So I suggest to be consistent, everyone, you put a practice here, you put a habit that every time when you draw the object, right, you take the upper boundary and the CF here. Then you draw, follow, this is upper boundary, this is a CF. Okay? Can Now, can we take 5 minutes break, everyone? Do you need a break or not? Okay, 5 minutes break. See you in 5 minutes times.